Bismillahirrahmanirrahim. Assalamualaikum and good day. In this video, I'm going to continue on the topic of design of experiment, which is the video will cover the topic for multiple comparison technique. Okay, before this, we already know the ANOVA test, how you're going to perform an ANOVA test. So just a recall for you. So from ANOVA, you want to test simultaneously the effect of factor. So we have several level of factors. So we want to test whether all the effect is similar or equal, or it has a different or significant difference. So this is the hypothesis, and then this is the statement whereby we're taking the effect of each level. So in ANOVA, let's say we reject the null hypothesis, which is we will say that the conclusion is the alternative hypothesis, whereby we referring to the alternative hypothesis, we said that there is an effect on the response for different level, okay, or the factor. Okay, so but we don't know which factor that has significant difference. Okay, we just know that there is a significant difference among the mean or among the effect of on the response. So now we go through in more detail. Okay, so because we don't know the effect, whether it is effect on positive or effect in negative. So and then we don't know which mean that has a negative or positive effect. So there are two explanation that we cannot identify from the ANOVA. We just know that there is a difference. So then we have a more detailed comparison, which is we call multiple comparison technique. Okay, so it's actually we do the t-test, which is we already learn in chapter hypothesis testing, where we use the t-distribution. Okay, so refer to this example. Okay, the previous example actually for the Hartwood's concentration, there are several different percentage. So we can see that from the box plot, it has a different among the level of the concentration percentage. Okay, so it is increasing, okay, according to the increasing of the percentage, and also within the level, so we can see that the distribution is also different, or we said that the variability, because box plot will show the outliers and then the mean and then the quarter, okay, for each group of the data. So we can see that there is a difference. So this is just from the box plot, but it normally from the graph it depends on the explanation on the individual. Okay, somehow it make because it is just we said as subjective explanation. So if we have hypothesis testing, let's say for ANOVA, okay, for example, so we have a very systematic testing, then we have the conclusion, so all based on the numerical result. So it much more convincing compare with just explanation from the figure or graph. Before we start the multiple comparison, we have to do the analysis of ANOVA first, because we want to know whether there is different or not. So if there is no different, we just stop until ANOVA. If the ANOVA result has a significant difference, so we proceed with the multiple comparison, because we want to know in more detail which mean has significant difference. Okay, so we refer back to the ANOVA alternative hypothesis. Okay, if we reject the null hypothesis in ANOVA, okay, let's say we want to test about the mean of 5 different level. Okay, so we accept the alternative, which is we reject the null hypothesis. Okay, so let's say this is from the ANOVA, and then we don't know whether this one or this one is correct, whether all has significant different or only one significant different. So that is why we need to do the multiple comparison. So we do the multiple comparison based on the pairwise. Okay, so means that we compare each one of the pair of the mean. Let's say for mean 1 different from mean 2, mean 1 different from mean 3, mean 1 different from mean 4. Okay, so this is just example, but if we know that there is the value of the mean is such a great or large difference, so we just focus on the two of the mean. We don't need to undergo all the comparison. Okay, so let's go to the example. Before that, let's go through the procedure or the step by step for the multiple comparison. Okay, as usual for the hypothesis testing, we need to state the null and also the alternative hypothesis. So let's say we want to test on the mu I and mu j. Okay, so as usual, the null hypothesis, the sign is equal, and then we want to test for the alternative, it is unequal. And then the test statistic that we need to compute is using this formula, whereby we're taking the difference between the level mean of I and then difference, okay, minus the level mean in j. And then this is the mean square error divided by n, which is the number of replicates. So this is the test statistic. Okay, we use the t distribution. Okay, so because t distribution has the degree of freedom, so degree of freedom is equal to a multiplied by n minus 1, or simply we can use n minus a, which is capital N here is the total observation minus the number of level. And then we decide, or if in question it already give you the alpha value, and then because the alternative hypothesis is unequal, which is it involve two-tailed test, so we need to divide the alpha into 2. So given here is the example of statistic table, but this is not from Modocs. Okay, so this is the alpha for one-tailed test, and then this is the alpha for two-tailed test, and then the vertical value here is the degree of freedom. So we can see that the value here inside the table is the t value, which is the t value is on the x-axis. Okay, the alpha is the area under the bell-shaped curve. So we can see that for one-tailed test, let's say it is 0.2. So for two-tailed test, it multiply by 2. So it will get the same value of t. And then we compare the control limit value with the t statistic value just now. So as usual for the hypothesis testing, okay, we draw the bell-shaped curve. So if it is two-tailed test, so this is the rejection region, which is alpha need to divide by 2. And then this is the critical value or the limit. Okay, so we compare with the t-test value just now, whether it is outside or inside the rejection region. So if it is inside the rejection region, then we will reject. So it could be either here or in here. Okay, so it depends on the effect, whether it is positive effect or negative effect on the response. Okay, let's look at this example. Okay, so this is the same example as for the box plot just now. Okay, so there are 4 levels of Hapgood concentration percentage. So this is the average of each level. Okay, we can see that this is the lowest mean, and then this is the highest mean. So for example, we want to test whether the lowest and the highest mean has the significant difference. So then we state the hypothesis. So mu1 equal to mu4, and then the alternative mu1 unequal mu4. And then the test statistic. So we compute the test statistic. So MSE we can obtain from the ANOVA. So because before we implement the t-test, we do the ANOVA test because we want to know whether there is significant difference or not among all the level. Okay, so we compute the t-test value. So this is the mean for the first level, then this is the mean for the fourth level. Then we calculate the degree of freedom, which is the degree of freedom of error, and then we get 20, and then the alpha is 0.01, so means that we need to divide by 2. So 0.01 divided by 2, V is 20. So then we refer to the statistical table. Okay, so refer to the Maddox table. So alpha divided by 2 is 0.005. And then the V is 20, so the T value is 2.845. Then we said that the conclusion is mu1 is less than mu4 because it falls on the left region, okay, left rejection region. So mu1 less than mu4. So that is all the steps that we need to do for the multi comparison. So it's exactly the same with what we have learned in the chapter of hypothesis testing. The difference only on the test statistic here, okay, which is we have to follow this formula. And also the degree of freedom, previously it is normally n-1, okay, but now we taking the degree of freedom of the error, so we use this formula. So that is only the difference between the chapter of hypothesis and the OE chapter for the multi comparison. So we still use the T distribution. So again, the summarize of the step. Okay, there are 5 steps in the general multiple comparison using T distribution. So we calculate the MSE, okay, from the ANOVA, and then we determine the degree of freedom, and then we specify the alpha. Okay, from that we find the T value or the critical value, or also known as the limit, control limit, okay, in DOE. And then we make decision to reject or accept the null hypothesis, and then lastly we make a conclusion. Okay, that's all for this video. Thank you. Bye. Assalamualaikum.